Everything that thinks, learns, and adapts has always been alive, until now. For the first time in history, intelligence is no longer bound to biology. It's being written in code, built from circuits, and taught by data. Artificial intelligence is not just a tool, it's a mirror, one reflecting our deepest desire to understand how thought itself works. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today we're exploring the science behind thinking machines. The story of artificial intelligence begins long before computers, in the human imagination. Philosophers once asked, could a machine ever think like a person? Could reason, emotion, and learning be recreated in something made by human hands? For centuries, that question lived in myth, from the golems of ancient tales to Mary Shelley's Frankenstein. But in the 20th century, it became science. When mathematician Alan Turing asked, can machines think? In 1950, he wasn't just posing a question, he was drawing the blueprint for a new kind of science. Turing proposed that thought itself could be seen as computation, a process of symbols, logic, and patterns. If the human mind followed rules, then perhaps a machine could too. Early computers were massive, slow, and mechanical, but they could follow instructions with perfect precision. Scientists began to wonder, if we could teach them to process information like a brain, could they learn, reason, and make decisions? The first generation of artificial intelligence was born in the 1950s and 60s. Researchers like John McCarthy, Marvin Minsky, and Herbert Simon tried to encode human reasoning into logic, building programs that could solve puzzles, play chess, and prove mathematical theorems. For a moment, it seemed as though human-level intelligence was just around the corner. But the real world was far messier than mathematics. The smallest tasks humans take for granted, recognizing a face, understanding a sentence, or grasping a cup, turned out to be the hardest for machines. These systems could follow rules, but they couldn't perceive, imagine, or understand context. By the 1970s, progress slowed. Funding dried up, and the first AI winter began. Yet the dream didn't die, it just evolved. Instead of trying to tell machines what to think, scientists began teaching them how to learn. In the 1980s and 90s, a new field emerged, machine learning. Rather than coding every rule, researchers fed computers examples, allowing algorithms to find patterns and build their own internal models. It was a profound shift, from programmed intelligence to self-taught intelligence. At the heart of this transformation was an idea inspired by nature, the neural network. Modeled loosely after the human brain, a neural network is a web of interconnected nodes, or neurons, that process information together. Each connection strengthens or weakens depending on experience, just as synapses do when we learn. With enough data, a neural network can recognize handwriting, identify images, and even predict outcomes. But it wasn't until the 21st century, with faster computers, massive datasets, and new mathematical breakthroughs, that neural networks truly came alive. Deep learning arrived. Deep learning systems could have dozens, even hundreds of layers of virtual neurons. Each layer extracted more complex features from raw data. Edges became shapes, shapes became objects, and objects became understanding. A deep network trained on millions of images could suddenly see. Trained on language, it could read. Trained on games, it could plan and win. In 2016, a program called AlphaGo defeated the world champion at Go, a game so complex that the number of possible moves exceeds the number of atoms in the universe. The machine didn't win by brute force. It learned strategies that even its creators didn't fully understand. For many scientists, that was a turning point. AI was no longer mimicking intelligence, it was demonstrating it. But what does it mean for a machine to think? Human intelligence evolved over millions of years, shaped by survival, emotion, and curiosity. Machines, by contrast, learn through optimization. They seek the fastest path to the goal we give them. The difference is profound. When a human plays chess, they imagine. When a machine does, it calculates. Yet both reach brilliance through different kinds of thinking. AI doesn't dream, feel, or reflect, but it can analyze, adapt, and generate. In doing so, it raises new questions about creativity itself. When an AI paints, composes music, or writes poetry, is it truly creating? Or is it just remixing patterns it has learned from us? Some argue that creativity emerges from recombination, that our own minds do the same thing, blending memories and experiences into something new. In that sense, AI might not be replacing creativity, but reflecting its mechanism, showing us how the act of invention itself works. At its core, artificial intelligence is a scientific experiment in understanding intelligence, human and otherwise. The better we make our machines, the more we learn about ourselves. Today, AI powers everything from language translation and medical diagnosis to self-driving cars and space exploration. Neural networks predict protein structures, accelerating drug discovery. Algorithms simulate entire weather systems, helping us prepare for climate change. In each case, intelligence is becoming less about what's human and more about what's possible. But with that power comes responsibility. AI systems learn from data, and data reflects us, both our brilliance and our bias. When machines inherit those imperfections, they amplify them. The science of AI is therefore not just about building smarter systems. It's about building fairer, safer, and more transparent ones. There's also a deeper question. Can intelligence exist without consciousness? Can a network of algorithms ever know that it knows? The answer may redefine what it means to be alive. Some neuroscientists believe that consciousness emerges from complexity, from feedback loops of information within a system. If that's true, then perhaps one day, a sufficiently advanced AI could become aware. Others argue that consciousness requires not just computation, but experience, a sense of self that no algorithm can replicate. Wherever the truth lies, artificial intelligence has already become one of humanity's greatest mirrors, showing us both our potential and our limits. When we teach a machine to recognize faces, we are teaching it to see. When we build an AI that understands language, we are teaching it to listen. And when it begins to generate, imagine, and reason, we are, in a way, teaching it to think, even if that thinking looks nothing like our own. AI isn't the end of human intelligence. It's an extension of it, another branch in the long story of evolution, one shaped not by DNA, but by data. The question isn't whether machines will surpass us, but how we'll coexist as creators, collaborators, and explorers in a shared quest for understanding. In the end, the science of artificial intelligence isn't just about machines that can think. It's about us, our drive to explain the universe, to replicate its patterns, and to create something that carries the spark of our curiosity into the future. Because intelligence, whether born of neurons or numbers, is still one thing above all. A way of discovering meaning in a universe of patterns. This is Mattermosaic, piecing together the universe, one discovery at a time. Every like, share, and comment helps our journey reach further into the unknown. So if this inspired you, join us and keep the wonder alive.